Oh, I can draw a better diagram. Slant face. At the center, a dipole is kept. Here, I think the negative charge is there. At these points, positive charge. Here is what a dipole is kept. So the dipole exactly, I think this will be the axis. Fixed at a minus charge is fixed at O. So this is O. Okay, let me give the number A, B, C, D. Okay, here a dipole is kept of dipole moment P. The slant length is giving, this will be slant length. And this is side length. This is a pyramid of square base. How the dipole moment will be along the height of the pyramid. So that this will be the height of the pyramid, no? Okay, it's asking find the force on the dipole and also the potential energy of system. Now look at this. So can these negative charge and positive charges, can they make dipole? This height of the dipole is given, sorry, height of the pyramid given A by root 2. Tell me what should be the approach here? There's another very good problem. I think I just booked up some textbook only. Now already there's a dipole there. So what shall we do? Shall we calculate the field due to the point charges here? But it's asking force on the dipole. There is a problem. So what shall we do? We'll calculate field due to individual point charge at the location of dipole. But again, the dipole, it's a short dipole. We don't have any other information. So what shall we do now? Shall we calculate the force exerted by all these 5 point charges due to dipole? There'll be the mutual, no? It will be. Now look at this negative point charge, where it is. It is present on the axis of a dipole, right? What about these things? They're present on the bisector of a dipole. So we can calculate this distance. We know this distance. Then what force experienced by them due to dipole? Equal and opposite force will be exerted by the experienced by the dipole. Am I right? Look at the approach. Then afterwards, we'll calculate the field at the dipole at point O due to all the point charges. Due to this, how much it will be? Due to this, the field will be in this direction. So I think at the location of dipole, due to these charges, resultant will be 0. Only due to this, it will come. Then go for U equal to minus P bar dot E bar formula, and you can manage. Getting the idea? So there can be questions of these kind also. You have to be very, very extra alert. So I'll do one thing. I will break up this problem into parts so that it'll be very easy for us. The first I'll start like this. Now let's only discuss about the dipole and negative charge point Q. So there's a negative charge and there's a dipole. So this distance is a by root 2. What is the force experienced by this? We'll calculate F minus. What is F minus should be equal to? F minus should be equal to 2p by 4 pi epsilon naught a by root 2 whole cube into charge, magnitude of charge Q. And how is the field? The field due to dipole will be in this direction. I think let me write E1. There's only E1. Huh? Then how it will experience force? F1 will be in this direction. So what is F1 equal to? Q into E1. So Q 2p 4 pi epsilon naught a cube. This will be 2 to the power of 2 by 3, 2 to the power of 2 by 3 plus 1, 2 to the power of 5 by 3. Check once mathematics. This would be force experienced by negative charge particle. Due to dipole. What about the the positive point charges which are there at corner? They will be similar to like a short dipole. No, how the field will be in this direction. So what about the force will be F2, and we know what is this distance will be a by root 2. What direction that force will be? That force will be downward. First we'll calculate what is field E2. E2 should be equal to P by 4 pi epsilon naught a by root 2 whole cube. So then the force F2 should be equal to Q into E2. So QP. Again, this also will end up same thing. One more 2 is there. No, I think I missed. Okay, that's one. Yeah. 2 to power of 3 by 2 QP or PQ. Just check. I think I'm right. Mathematics, you check once. Okay, this much is what? F2 we got it. So like this, 4 point charges are there. So what is the net force exerted by the dipole on all these 5 point charges? I think F1 plus 4 F2. Four times. Okay, solving this, we'll get the, I think, PQ 4 pi F naught AQ will take outside. This will be 2 square. 2 square again, this will all 5 by 3 or 3 by 2 or 2 by 3? Cube root 3 by 2. I think 5 by 2 it is. Check once. This will be 5 by 2. I think it should be equal to Anybody just confirm the final? Again, this 2, if you send it, the final answer will be 3/2. Anyway, just verify it. If it is right, okay, I'll proceed further. What is this Fnet? By the dipole on all the charges, or by all the charges on the dipole? Confirm. Shall I confirm this as answer? Check calculation once and tell me.
Sir, it should be 2 to the power 3/2 into 6 pq by pi epsilon naught a cube, sir.
6 pq, why?
Sir. It is 5/2, it is 3/2. That 4 is also there, no, sir. 4 plus 2, 6, no, sir.
Okay, this 4 is there. So this 4 will become 2 square, no? Oh, 2 square, it will be. Okay, I think not 1, no, it is a 2 square. Some calculations. How much it will become?
2 to the power 3/2 into 6 pq by 4 pi epsilon naught.
2 to the power of 6 pq by 4 pi epsilon naught. Can't we write this further? I'll write it in better way. 6 pq by 4 pi epsilon naught a cube. This much, huh?
Yes, sir.
Yeah, fine. Okay, say nothing big. Already what we know, we have just applied it. Okay, after this, I want potential of system. Not interaction potential between dipole, overall potential. For what we should do for this? There'll be interaction between the charges and also between the dipole. First, we'll calculate how much of energy interaction between the charges and the dipole. I think that'll be easier. So for that, what will be the field due to each point charge at center will be 0. Only due to this it will come. So interaction potential between the dipole and the charge will be only between due to this minus Q and P. Fine. This is one thing. Next again, interaction potential between these charges. The sum of all that has to be written. So I'll conclude everything. The potential of system should be equal to the negative charge. So this will be minus P Q by 4 pi epsilon naught A by root 2. Please make observation. I'll minimize it. Yeah. See, what I'm doing is like, due to this positive charge, the field due to these two will be equal and opposite. The field due to these two will be equal and opposite. So due to these charges which are there at corner, what will be the resultant field at the position of dipole? Will be 0. Okay, this one. Due to negative charge, the field here will be upward. So angle between P bar and D bar, cos 180, cos 0, 1. So minus P, what is the field due to this will be Q by 4 pi F naught A by root 2. This is due to interaction potential between the dipole and charges. After this, what you should bring? The interaction potential between them. Between AD, then AC, AB, then DC, CB, then BD, then again the interaction between all these charges with the point 2. UAB, UAC plus UAD plus UBC, UBD plus UCD. This is 1. Then afterwards, 5 interactions. Minus K Q square by A. Able to, what is this? What is the distance between the like a charge which is there at the point O of the pyramid, which is apex of the pyramid and the corner. The separation is A, no, slant length, and K Q square by like that. 5 interactions will be there by this. I think 4 interactions, sorry. 4 interactions. This point charge will interact with charges kept at the corner. 4. What about this? This